Hey guys, so today in class we looked at the rain gutter problem, and so just a little recap here. We had a sheet of metal that was 30 centimeters wide, so that was a given, and we are going to fold or bend this metal so that it's into a trifold where each of these is 10 centimeters wide. And then we're going to fold it up, so this is the sheeting here, this piece that's 10, this piece that's 10, and this piece that's 10. We're going to fold up the sides of this rectangle, so if you can imagine it turning sideways, to make our rain gutter, and then this would represent just like the top of the rain gutter if it was filled with water. So this is like if it had been raining and it filled up. Okay. So the question asked us, or the goal of this problem, was to find the maximum volume of such a rain gutter. And we talked about in class today how the maximum volume really means that we just want to find the maximum cross-section, or maximum angle, or area, sorry, of a cross-section. So we're really just going to try and maximize this area, and by doing that, we can know that we're getting the maximum volume no matter what the length of the gutter is. The gutter doesn't matter, or the length of whatever gutter we're using doesn't matter. So to do this, we need the area formula for a trapezoid, because we're working with a trapezoid here. So area is 1/2 height, which is measured there, times base 1, which for us, base 1 is always going to be 10 centimeters, plus base 2. And base 2 is the top base for us. Okay. And we looked in class at changing the angle that we fold this at. So for instance, we could make it be a 90-degree angle, where this is 10 and 10 and 10. Or we could open that angle up a little, right? Fold the paper or the metal sheeting open a little. This is still 10, 10, and 10. But notice when we do that, we get a little bit wider, but we also get a little bit shorter, so it's not quite as tall. And then we could open it up even more. Maybe make it look like it's more open. And again, it gets shorter but also wider, so maybe that's helping us with the area, maybe it's hurting. And so we really have two things here. We have the height and we have that second base, but they're depending on whatever this angle is, how open or closed we make our rain gutters. So I'm going to call that angle theta for right now. And we're going to be trying to set up an equation based on theta. Well, now let's look at just some hard numbers here, and we're going to use actual numbers to sort of set up our equation. So I'm going to make a guess. I'm going to go ahead and just draw a rain gutter. By the way, please include this in your notes. So I'm going to label that guy 10, 10, and 10. The height, I don't know. And I'm going to say that this angle is going to be 110 degrees. So I'm just making a guess here. My theta, my angle, is 110 degrees. Okay. Now, to find the height of the gutter, well, I probably want to know what one of these little interior angles is. So I notice right now that that angle right there is going to be 110 degrees minus 90, because it's less that right angle. 110 minus 90 is 20 degrees. Okay. And then once I notice that that's 20 degrees, I can label it. And now if I want to find the height, that angle is adjacent the height. I'm zoom in here so you guys can see a little better. Okay. So if this is adjacent and I have 10 as my hypotenuse, I know I can use cosine. So I'm going to say the cosine of 20 degrees equals the adjacent side, which is my height, over my hypotenuse, which is 10. So that means 10 times cosine of 20 equals my height. And then I grab my calculator, I make sure that my mode is in degrees, and it is, and so I'm going to take 10 times the cosine of 20, and I get a height of about 9.396, so I'm going to say 9.4 centimeters. Once I know the height of this trapezoid, now I need to figure out what my base 2 is. But my base 2 is dependent on how wide this little bit of the triangle is, because that's going to show up on both sides. So I need to give this a variable. I'm going to call it z. By the way, in problems like this, when you're trying to assign things variables, Staying away from x's and y's in the beginning is sometimes helpful. just as a little side hint. So I call that guy z. I notice that there's two ways to get it. There's two ways I can do this. One of them is to notice that it's the opposite side. So I could use sine, opposite over hypotenuse. Actually, there's a bunch of ways I could get it. So I could do sine of 20 equals opposite over hypotenuse and get z that way by multiplying both sides by 10. That's a nice way to do it. I'm kind of a fan of that way. I also could use the Pythagorean theorem potentially. So you could say that, like, let's say h, which is 9.4 squared, plus z squared equals 10 squared, and you could solve for z using the Pythagorean theorem. So you could keep going and get z that way. Personally though, I'm gonna have to square something, I'm gonna square something over here, I'm gonna have to be square rooting. This seems like more steps than just multiplying by 10, and so I'm gonna go with this one just because it was easier, with fewer steps. So 10 times sine of 20, I'm gonna go ahead and do it on the calculator. Good old calculators, and I get 3.4 centimeters for z. And now notice that B2 is going to be equal to z plus 10 here in the middle, plus another z. Or if I wanted to combine like terms, I could say 2z plus 10. So in this case, B2 is going to equal 2 times 3.4 plus 10, which gives me 16.8 centimeters. And now, as far as the area formula goes for the trapezoid, I know the height, and so now I can find the area of this one guess and check. So I'm going to go ahead and say area equals 1/2 the height, which was 9.4, times base 1, which was 10, and it always is 10, plus base 2, which is 16.8. And I get the area equals 0.5 times 9.4 times 10 plus 16.8 is, let's see, 125.96, and this is centimeters squared. Now, I know that I took a lot of time and you're probably sick of having to write all this stuff out, but by writing everything out really carefully, we can now take our work that we used with a specific example and we can generalize it, which is a really powerful tool in mathematics. Working through the math with numbers is always easiest to do first, and then turning the math into general, like using variables instead, is going to help us do this to check answers across the board. So the thing that's changing here is this angle, this 110. Every calculation I did was based off of this starting point. And I said theta was 110. Okay. So I'm going to let theta be my variable. It's going to be like my independent variable. So theta is equal to my angle. And now I'm going to trace my way back through my steps. So let's see, the first thing I did was do 110 minus 90. So I'm going to say theta minus 90 is going to be that little angle inside the triangle. That guy right there, right? And then, if I follow my work down to find the height, I did cosine of that 20 degrees, so I'm going to do cosine of theta minus 90, and that's going to equal my height over 10, and then I multiply both sides by 10 to get my height. So I have 10 times the cosine of theta minus 90 equals my height. After I found the height, I had to find that little z. That was what I did next. And so I took sine of 20. Well, I know that 20 came from 110 minus 90, which came from 110. So I'm going to do the same thing here, but instead of 20, I'm going to write theta minus 90. So I have sine of theta minus 90 equals z over 10. And I multiply both sides by 10, and I get 10 sine of theta minus 90 equals z. Now notice after I found z, I found my second base. It was 2z plus 10. So my base 2 is going to be 2 times z plus 10. But instead of z, I'm going to use what z is equal to. It was 10 sine of theta minus 90. And then last but not least, I took what I knew. I took my h that I had found, and my b1 and my b2, and I plugged it all into the area formula. So I'm going to do the same thing down here. area equals 1/2 the height. So let's see, I've got to go find h. There's my height. So let's see, 10 cosine theta minus 90 times my base 1, which is 10, plus my base 2, which is this whole thing. Let's see, 2 times 10 sine theta minus 90 plus 10. Ooh, I'm running out of room there. Okay. And now I have this equation that has a variable for a and another variable, so I have two variables, and I'm trying to find a maximum rain gutter. I want to find the biggest rain gutter that I can find. So what I'm going to do is I'm going to plug this into my graphing calculator. Now, let's see, I need more paper so I can keep going here without having to lose all of that work. Okay. So I'm going to say y equals 1/2. Well, let's see, I can simplify this even more. Half of 10 is 5. So a equals 5, that's better. Cosine of theta minus 90. Okay. And then that's times, let's see, 10 plus, well, 2 times 10 is 20, so I can simplify that at least a little bit. So I have 10 plus 20 sine of theta minus 90 plus 10. And then here, 10 plus 10 is 20. So 5 cosine theta minus 90. 10 plus 10 is 20. Plus 20 sine theta minus 90. And, you know, frankly, you don't have to simplify. I'm just doing it so there's less to plug into the calculator, basically. I don't want to have to plug in as much. And now my area is going to become my y, and theta is going to become my x. Sort of hence me saying don't use x's and y's, because you're going to use them at the end. Now I go into my graphing calculator. And I'm going to plug in 5 cosine of x minus 90 degrees, and then parentheses 20 plus 20 sine x minus 90. Make sure I've got, let's see, close, close, that's 1, 2, 1 open. That looks good, and that looks good. Okay, next I have to fix my window. So for my window, there's two ways you can do this. You can think about the actual problem. For instance, the angle here that we're talking about, our theta or our x, I mean, it really doesn't make sense to make it be anything less than 90, because you're going to start having like closed off rain gutters. And you obviously can't have it be more than a straight line, which would be 180. So that makes me think that our x or our theta has to be between 90 and 180. Which means for my x-axis, I'm going to want to go between, for my window, my x's should go between 90 and 180. With maybe a scale of like 10s, that works. Now, if this makes you nervous, you could always go from 0 to 180, that's fine. It would just be a completely folded in on itself gutter. And then the y value is obviously the smallest area we could get would be 0. The most area we could get, well, so far, we have one data point of 125. So let's go kind of in the same vicinity as that, but just a little bit bigger. So maybe like 200. You can also use your XY table to help you figure it out. So for instance, if I go table set, start at 0 and count by 10s. Notice that when your rain gutter is folded on itself, it doesn't hold hardly any water, right? We're moving on up, moving on up. Looks like it hits 129. And then it's starting to get smaller here. So I guess 200 would be a good thing. I could probably also just go up to 150. Okay. And then I graph it. And you see I get a nice smooth curve here. This is representing on the x-axis the angle, and then the y-axis is my area. And now if you solve this graphically to show your work, what you would do is include a graph. So x is my angle, measured in degrees. The y is the area, measured in centimeters squared. Up here is 150, out here is 180, and I'm getting this nice, pretty curve just like that, kind of. And then I want to find the maximum area, so I'm looking for the height of that curve. So I'm going to hit second calc, go to max. left bound, it's on the left side, so I'm gonna hit enter. The right bound, you can either scroll or you can type in, like for instance, if you know it's gonna be 120 or more from the table, the XY table, then you could type in like 130 and that would get you to the right side of the max. And then hit enter for guess. And it gives you a maximum of 120. Now 0.000002 or 01 like that, that's just 120. And 129.9. Okay, so this is my angle that gives me the best rain gutter, and this is the area of that maximal rain gutter. Okay. That's it for notes tonight, guys. Make sure that on your work from today that you rewrite it if you need to so that it's legible so anybody could read it, and I will see you in class tomorrow. Thanks.